Welcome. This question says a source of sound radiates energy in all directions. The source radiates 10 joules of energy each second. And then what is the intensity of the sound at a point that is 2 meters from the source? So let's picture it first of all. Here's a source of sound, and I'm gonna show the kind of energy moving away from the source. If you imagine that's like a compression wave moving away, and it's going to go in all directions evenly, so it's spherically symmetrical. And you can kind of see as it moves away from the source, it spreads out over a bigger and bigger surface area of a sphere, and that's why it gets less intense. This question's, so what am I given here? I'm given the source of sound's energy per second, and so my power, which equals my energy per second, which equals 10 watts, because it's 10 joules per second. They named the joule per second after watt. And then we have the distance. So this is my R, let's call it R. So R is equal to 2 meters. So then what is my intensity? My intensity is equal to the power over the area that the energy per second spreads over. So in this case it's going to be equal to 10 over, and the area is going to be 4 pi r squared, of course. And so I is going to equal 10 over 4 pi times 2 squared, which equals 10 over 16 pi. So my intensity is equal to, if I just bung this into my calculator, I'm going to get 0.199. And the intensity, if you look at the expression, is going to be watts per square meter. So there we have it. This question lends itself to ratio problems where I could give you the power at a certain distance and then double the distance or triple the distance or quadruple the distance, and you'd recognize it's an inverse square law. It's inverse squared because of that 1 over r squared. So then if I double the distance, I get a quarter of the power. If I triple the distance, I get 1/9 the power, etc.